Hello, welcome everyone to this session today. So, uh, ma'am, may you start this session, or shall I start asking the questions what they do have doubts in? Ma'am, you are on mute.
Yeah. You can start some basic information. You can give them some basic information. After that, you can give some doubt clearance things after that. Because we are doing using Arduino, some sensor. We're mostly doing some projects. Most of the school are doing same like things. Yeah. So yeah.
So then what I will do, I will explain the Arduino first. Okay. I will
Yes.
explain the Arduino from the basic to the advanced level so that further they can add on their questions in between and help me with the doubts they have.
Yes, sir. Sure.
Okay. Allow me to share my screen to showcase the Arduino Uno board. Okay. So here we do have. Okay, before jumping into this topic, especially, let me tell everyone about myself. My name is Sourbh Kumar, and I'm one of the person who is involved in this STEM and robotics journey. And as a guide, you can look into me as a guide or mentor. Anytime you do have any doubts, then ping me over. I will help you out on those topics. Okay. So the robotics itself, like always we discuss in terms of robotics and AI and everything. So anyone, may you help me with the proper definition? What is robotics and what is actually the AI part of it? Anyone do have any idea about robotics and AI? Anyone from the student side? Okay, so even though if you are unable to unmute yourself because maybe there will be some problem or something, you can drop your answers in the comment section or the chat section in here. So whenever we discuss in terms of robotics, so robotics basically composed of three individual pieces, or we can say that the part of robotics. So in those parts, what we do have is the input device. Okay, so input device is nothing but we are talking about the sensors to take input from the environment, right? Even though to collect the data from the environment and to understand what is happening around the robotics body. Suppose if you are making any of the robotics body, even though like the humanoid or the car or line follower car, each and everything does require three things to operate. And sensor actually helps them to understand the robotics structure, to visualize the stuff happening around them. So what else we need in here? The brain of robotic system. And why we need to have the brain? Because brain is responsible to do the processing of the data coming from the sensor side. And further, we are using those data to produce the third part. To produce what? The output. So the brain similarly, like one of the brain is mentioned in here in this picture is what is this one? The microcontroller, right? So the microcontroller, or we can call it the Arduino or the development board. So whenever you will come across these type of boards, we'll call these boards as development boards or the brain of robotic system. These development boards help us to understand and to process the data, help us to understand what are the signals are coming from the sensor side and understands the data and further process the data to produce the output. Output should be will be in the form of actuation. Actuation means to produce some of the motion, or we can say that the locomotion part. Okay. So apart from the actuation, there are other method of generating the output as well present in this robotics journey. That is the in form of light, in form of sound. So how we can produce the output in form of light? Using different type of LEDs, right? LEDs and light bulbs and all. And to produce the sound, what we do have is the buzzer to like produce the tone or something high pitched tone. Buzzer is used one of the type of sound output through which we can able to generate the high tone outputs. But instead of buzzer, what we can use different combination of speakers to produce desired output in terms of sound frequency. Okay, so like the audible region or even though the speech we use in our robotic system. So actuation, and apart from this light and sound, I already mentioned two of the terms, that is actuation and locomotion. So whenever we speak in terms of actuation or locomotion, means we are referring to the motion producing agents in here. So motion producing agent will be motion or the force producing agent. So motion or force producing agent will be the motors itself. And there are various type of motors present in the market, like DC motor, BO motor, and servo motor, stepper motors, and so on. You can count on these type of equipments to find suitable for your robotics project. So suppose if we take example of the line following robot, then specifically the line following robot robots does require input system in which we implement different type of IR sensor arrays, and the processing unit the processing unit will be our Arduino boards or any other development boards, right? And third one will be our output. And to generate the output in line following robot, we always use the BO motors, PO motors or DC motors in between. So these will be the common scenario to build any robotics body or the robotics structure. So whenever we take these kind of development boards, so we do not call this type of development boards as a complete microcontroller. Okay, these one are the development boards. The reason why we do not call this kind of boards as the complete microcontroller, because microcontroller is the subset of the development board. So this one in here present, the IC in here present in between is the microcontroller in our development board. Okay. So specifically the Arduino, does utilizes one of the microcontroller manufactured by Atmega company, and the model number is the manufacturer is Atmel company, and the model is Atmega 328PU. Okay. And what else? We do have, instead of the Arduino development board, we do have several type of different type of microcontroller present in the market. Even though some of them are comes at very nominal cost, like the Node MCUs. Node MCU works with the ESP8266 development microcontroller. So Node MCU board is one of the famous board because it does have the Wi-Fi capability inbuilt, means Wi-Fi connectivity options inbuilt. But Arduino board does not have any of the connectivity options inbuilt. You have to integrate the Bluetooth module, or you have to integrate other Wi-Fi or GSM based module to provide the internet or the connectivity option. So there are several devices, even though like the Node MCU itself comes with the Wi-Fi. So we usually call those boards as IoT enabled boards. Okay. And one more thing, apart from the this particular Arduino boards, the Arduino R3 Uno boards, and we do have another kind of that is the R4 board. R4 board does utilizes ESP8266 microcontrollers, and it does have the Wi-Fi capability. So the upgraded model of the Arduino itself is one of the IoT enabled microcontrollers. So in here in the microcontroller, if I try to explain you in a details, and what you can say, we do have this A to B type of port in here to establish the communication between the computer and the microcontroller. And also what we do have is the DC jack.
Yeah, I got it.
DC jack. Okay.
Can everyone mute yourself, please?
Okay, fine. So now we do have the DC jack. So there are three alternative methods to power our device, to supply the power to our device. One, either we can utilize the USB jack or the USB port available in the Arduino boards itself, and other one is the DC jack. Okay, so there will be a power difference, obviously. The second one is the DC jack. The first port utilizes 5 volt in total coming out from the computer system or the power bank itself. We can use this particular port to power up our Arduino development boards. And second, the DC jack does utilizes the recommended, or we can say that the recommended voltage we should use in the DC jack will be 7 volt to 12 volt. Okay, not more than that and not less than that. Even though it will work properly with 6 volt and 5 volt, but that's not the recommended voltage. And even though after the 12 volt, what we do have 13 volt and 14 volt, it will work with for up to 14 volt as well. But the 12 volt is the maximum recommended voltage to be used in the development board. And the third method which we can utilize to power up the Arduino development board or any other microcontrollers, that we will find this particular pin in each and every development board. Even though the Node MCU and other microcontroller does have the V in pin. So through the V in pin, we can actually supply the positive voltage. Because if you recall that, recall the concept in the power transfer, you will probably heard of the positive terminal and negative terminals, right? So we are referring the positive ones as the V in pins, and in the V in pin itself, we can able to provide 5 volt to 12 volt to turn our microcontroller or the development board on. So in here in the Arduino microcontroller, this one is the power section. This section is completely the power section, and through the power section, either we
कोई
can,
ना वहां से
yeah, Divya's iPhone, please mute yourself. Okay. So power section, through the power section, we can able to either supply the power to the board, or also we can pull the power from the board, because each and every input and output device, like the input device in term of input device or the sensor.
What did I do?
Okay, even though the input device like the sensor itself does require some of the powers to work, right? Some of the powers to work. If you look into the any of the sensors like the IR sensor, so IR sensor does have 3 of the pins in total. So one is the positive pin, other one is the GND pin, and third one is the input pin for the Arduino. So it does require power to operate. So how we will get the power to operate different devices around, like the sensor device and output device? So we can utilize this power section to power up our sensors and different devices or different components attached to our development board. So we do have the 3.3 volt pin, we do have 5 volt pin, we do have 2 GND pins, and GND is nothing but the, it represents the negative terminal of the power source. Okay, GND is nothing but the negative terminal of the power source. Okay, so through this one, what we can say, this power section can be used to address both of the scenarios. First one is to take the inputs from the outside world, and also to provide the output in terms of power to different components connected to the Arduino development board. So we will call these boards as development boards only, not the microcontroller, or we can call it by other names as well. The development boards should be called as brain of robotic system, because in the brain itself, we insert the program, we write the program inside of it, and further it tries to process the data coming from the sensor and provides us the output. Okay, in terms of the 3 scenario I discussed earlier, the locomotion, actuation, and light, through the light mode or the sound mode, we can generate different type of output based on our requirements. Okay, so okay, after the power section, what we do have on the left hand side is the analog section, analog input section in total. So why we do have analog input section, and what is exactly the analog? So let's discuss the digital and analog function first, then we will come back to the development board itself. So we do have two kind of operation, two mode of operation in total to control the input and output in any development board. So digital, whenever we talk in terms of the digital system or the digital means, we are talking about two of the fixed value, either 0 or 1. Means there will be two specific values, 0 and 1s. So 0 will be used to address the off condition, and 1 will be used to address the on condition. Okay, and off condition, and how we will address the same in our programming environment, because these kind of development board does require some of the programming, right? So we are talking about the embedded C++ programming. So we will operate this development board using the embedded C++ programming. C and C++ is the conventional way of programming to generate or to develop some of the user interface. But whenever we insert the embedded in front of it, that means we are talking about the programming for hardware devices. Okay, we are talking about the programming for hardware devices. So in embedded C++ means we are talking about the programming for hardware devices. So off condition will obviously will be termed as the low condition in embedded C++ environment, and on condition will be considered as high condition in our embedded C++ environment. Okay, you should remember this, or if you do have a copy and pen, so note down this particular point for your reference. Okay, so now what we do have is the analog session. And why we need to have the analog session, an analog system or analog things in here, because the analog itself represents the data in between 0 and 1. Okay, the analog represents the data in between 0 and 1, means we can say that the analog is the range between 0 and 1. We are talking about the range between 0 and 1. And further, if you look into this picture, I can give you the similarity to understand which type of component we are considering as digital system and the analog system. Let me give you a short and quick example, which is readily available in your home as well. The digital means, suppose you do have different kind of electronic appliances in your home, right? The fan, bulbs, and everything, right? Appliances means the things you do use in your home on a regular basis, right? So how to control the fan? How you control the fans? How you turn on and turn off the fan? Using
With the
what kind
switch.
of things? Yeah.
With the switch.
Regulator
Yeah,
to
perfect. The switch itself. So using this switch, what we can generate is the off condition and on condition. So remember the digital example for the digital one as off and on condition. Okay. So whenever this will come to your mind, what is digital? So remember that example of switches present in your home to turn on the device and turn off the device. Through this switch, we are only generating two of the values, either on or off condition. But if we talk in terms of the analog device, then we are referring to one more example which is readily available in your home. And what was that? The regulator itself. The regulator itself, regulator means to control the speed of fan. You do have one of the electronic device in your home, right? Yes or no?
Yes,
Yeah.
sir.
So regulator helps us to turn, means first switch on the fan, and then if we try to rotate in a clockwise direction, then it will increase the speed of fan up to the full speed, right? So we are generating the data in between the 0 and 1, right? So 0 will be here, represent the off condition, and 1 will represent the on condition, but as well we will get some of the values in between, like 0 0.1, 0 0.2, 0 0.3, 0 0.4 up to 1.0, right? So this value can be controlled using the analog function. And why we need the digital function and analog function in the programming environment in this kind of robotic system? Because sometimes you have to gather the data from the environment, like the temperature itself, right? So temperature is not the fixed value or not the on and off condition. So you have to take consideration of the some of the variables value. So whenever we will address the variables in our programming, we will refer to those as analog system. And the time when you only have to turn off and turn on the system, we will focus on digital system. Okay, so we'll focus on digital system. I hope the doubt is clear regarding digital and analog system, right?
Yes, sir.
So let's head back to the Arduino itself. Okay, so we do have this analog input section. So analog input section is designed specifically for the analog devices to take the inputs from the analog type of sensors. Okay, so those devices which are helping us with the analog signal can be connected to the A0 to A5 pins. Okay, and what are those analog sensors or the analog devices? Like temperature sensors, temperature sensor or heat sensor, or we can call say that humidity sensor, and so on. There are plenty full of example present in the market to address the analog inputs. Those are not the fixed value. Those sensors generates the variable value will be addressed using the analog input pins. Okay, and apart from this analog pin, what we do have this side is we call this side as IO pins. And what are the IO pins? So IO stands for input and output pins. Okay, input and output pins means we can either generate the input and output from the pin number 0 to pin number 13, or total 0 to 13 we do have on the right hand side, right? So we can either take the input from these pins, or can able to generate output from this pin. But make sure that suppose if you connected one of the device to the pin number 0 to take the input, do not connect the same to generate the output from the same pin. Okay, otherwise it will contradict with the programming itself. So always use single pin for single purpose, either to take the input from the sensor and also to generate the output to any of the output device. Means either we will connect any of the sensor to a specific pin, or connect any of the output device like the motors and others to the specific pin. If you notice to these 0 to 13 pins, some of the pins does have uh, engravings on top of it. If I zoom into this page, you will look if you look closely, you will find that some of the pin does have this symbol. Yes or no? It does have this symbol on top of it, like the pin number 11, pin number 10, pin number 6, pin number 5, pin number 3, right? But other don't have that symbol in front of it. So this symbol actually signifies the PWM pins. PWM pins stands for pulse width. Yeah, correct. Sanath, right? Pulse width modulation. And what does it means? Why to have the pulse width modulation? Alike, we do have analog pins dedicated to the left hand side to take the inputs. Those PWM pins can be used to generate the analog output. Okay, those pin can be used to generate the analog output in total. So why we need to have the analog output on first place? Let me explain you that. So suppose let me give you one scenario again for the line following robot. Okay, the same example. Suppose my line follow we built one line following robot, and the line following robot is following this particular path. Okay, and this one is the start point and this one is the end point. What will happen if we try to start from this particular point? The common common question in this particular line following car competition will be our timings. Those students who will complete the arena in minimum possible time will win the competition, right? So we have to complete the entire arena in minimum possible time. So how we can able to like complete the arena in minimum possible time? To move in a straight line like this one as fast as we can, right? But if you look closely, we do have a straight line in here, but we have to take sharp right turn on this particular place. If I name every point A, B, C, D, E, F, and G, then the bot is required to take a sharp turn on B, C, D, E, F, right? So the time when we are taking sharp turn, what will happen? You maybe heard you may be studied in your science subject that if we are in motion and if we are taking any sharp turn, what will happen? The car will start pulling us in outward direction, right? And further it will flip or it will lose the path. So what it need to be done in here, we have to slow down in this sharp corner, right? slow down in the sharp corner. And that place, what is required to have is the analog output. So from this place, we will use the analog output to reduce the speed to some extent that our card won't flip and it will properly follow the path in between. Okay. So this is the whole scenario for the Arduino development board. And apart from this, we do have several things mounted on board. Let me show you once. Then further we'll move into the doubt clearing session. Okay, so if I zoom into this page or to this development board, what we do have is one of the LED named L is mounted on board, right? And this particular LED is directly connected with pin number 13. So whenever we will do the programming for pin number 13, then what we are actually doing, we are addressing this particular LED. This LED will also flash or pop up or turn on whenever this pin will be in high condition or on condition. Okay, and after that what we do have is the TX and RX option in here, or the LEDs mounted on board. So TX represents the transmission protocol and RX represents the receiving protocol. Okay, so whenever our microcontroller will communicate with the computer system, then suppose if computer is sending some of these signals to the microcontroller to communicate, then what will happen? The RX LED will show up. That then it will inform us that something is the microcontroller is receiving something from the computer, and the TX will glow when the microcontroller will try to communicate with the computer system. Okay. So after that, what we do have, like we do have the watch in our hand to keep track of the time, or the mobile phones to keep the track of the time. The microcontroller or the development board does have these kind of component. This one is known as the crystal oscillator. This
Yes,
one
so
is
it
the
oscillates
crystal.
10 to 30 seconds.
Sorry.
So it oscillates 10 to 30 seconds for the function.
Yeah, we can say that, but specifically in terms of the if you go for the engineering explanation for that, I will prefer to say that it does have some of the frequency to oscillate. Specifically, this oscillator does have the 16 megahertz frequency in which it's oscillate, and further it provides the signal to the microcontroller to identify what time it is based on the calculation happening inside of it, based on the function itself. Okay. So after this, what we do have is this kind of things mounted on board. This one is the voltage regulator, which is mounted on board, because the time when we will use this DC jack to supply 7 volt to 12 volt, we need to reduce the power to some extent. And microcontroller does only does require 5 volt of power to run. So this is one of the voltage regulator mounted on board. Model number is 7805 to reduce the voltage to 5 volt, and further it will be supplied to the microcontroller mounted on board. So this particular device help us to reduce the voltage in between. And you know why to have the capacitors in the electronic circuit? Because to reduce the we have to reduce the fluctuation of energy, or the capacitor itself stores some of the energy and supplies it back whenever we need them the most. So it does reduces the fluctuation in the circuitry. And one quick question will be for you guys, like suppose we do have 3 mode of uh, supplying the power, right, to this development board or the brain of robotic system. Suppose if we supplied the power from this power jack as well, and a power jack and the USB adapter as well, then what will happen? Which port it with this microcontroller will utilize to take the power from? How you can come to that conclusion? How the microcontroller will take the power from the?
Sir, I think the USB.
So it can take through both of them.
Okay. Okay, that was okay, but yes, but no, we do have different type of comparator mounted on board. The comparator mounted on board the comparator actually compares the voltage coming from the DC jack and also from the USB jack. So the strength and the quality of the power signal will be good from the USB. Then what will happen? This will reroute the power from USB to the microcontroller. Otherwise, if the power is strong and steady from the DC side, then it will reroute the power from the DC side to the microcontroller. That is how the power is being distributed inside the board. And apart from these, what we do have these kind of six pins. Some of the board does have pins in here as well. Six pins. These are known as the ICSP pin to utilize this
For
development.
in-circuit serial programming
Yes,
pins.
correct. Perfect. So these kind of pins can be utilized to program other microcontrollers in between. Suppose we are going to use, suppose if we try to utilize the microcontroller only in our project and we need to program this microcontroller, then what we will do, we will connect the microcontroller directly on breadboard setup, and further we can use ICSPs to program the microcontroller or other microcontrollers available in the market. Even though we can utilize the pin number 0 and 1 for the same, the TX and RX can be used to communicate further with the other microcontrollers or the development boards present around. Suppose if the USB port is faulty or it's not working properly, then we can utilize these pins in total to help us out in these scenarios. Okay, so I hope the detail is clear to you. If you do have any question, then please let me know so that I can further help you with your doubts in this topic. We received one of the, okay, not in the chat section. Okay, fine.
I have a doubt.
Yes, please go ahead.
Can we connect an Arduino with another one?
Arduino with what?
Can we connect an Arduino with another one?
One Arduino with another Arduino, right?
Yes, sir.
Yes, we can do that. We can do that using the 0 and 1 pin, the TX and RX pin. And further, one Arduino will communicate everything to the other Arduino, and based on our programming, it will execute the task.
Sir, I have a doubt.
Yes.
Sir, what is the AREF pin?
Which one?
Sir, the
Okay.
AREF
AREF.
pin.
AREF.
Yes, sir. Yes, sir.
Yeah. AREF, okay, we do have, this one is not the UND, this one is the GND pin. As I explained, GND can be addressed to address the negative terminals in our power section. Okay, so these GND pins will come handy to address the negative portion of the things. One more thing is there in here is the reset pin. So reset pin can be used to address. Okay, let me show you one thing. Okay, here itself we do have one of the reset button, right?
Yes, sir.
So this particular reset button is actually, okay, let me draw one of the symbol to represent the reset button. So reset button will obviously have two of the terminals. Right now it does have the 4, but only 2 of them is required for the same, right? So these 2 terminals can be used, like one will be connected to the GND and other is connected to this particular reset button. So reset button can be used to address the suppose if my program is stuck in between, then what we need to do is hit this button at a time, then it will further help us to reset the program and it will start reading the program from line 1 to line 10 or whatever the line will be at the end of this. And this one, the AREF, is the analog reference pin, which will be used to provide the reference from for the analog device, or we can say that the analog devices sometimes does requires this pin particularly. For example, what I can say, some of the analog devices are there which does requires this pin, analog reference, or we can take the values difference from this pin itself.
Yes. Yes, sir. One question. So this is this ARF voltage that we provide, that is the analog reference voltage for the comparator and conversion from analog to digital, right?
Yeah, correct.
Okay. Suppose, let's say the default analog reference voltage is 5 volts, right, sir? Right?
Okay.
And then let's say if we connect some other amount of voltage, let's say let's assume 2 volts into that ARF pin, but if we forget to declare in the code that analog reference to our particular voltage, and instead just write analog reference in brackets default, then what will be used as a reference voltage in the comparator?
It won't work properly, dear. On that case, it
Okay.
won't work properly because if we talk
Okay.
in terms of the input and output in here, we are talking
Mm-hmm.
about the zero. Suppose if we are talking about the off condition and on condition, then we are referring off condition as 0 volt, right?
0
And on
volts.
condition as 5 volt. So
5 volts.
microcontrollers by default will take the 5 volt to be to the maximum reference voltage. Okay.
Okay.
Suppose if we are getting more or less than the 5 volt, then we have to declare it in our programming. Then only the ADC will work. Like you maybe have
Okay.
the knowledge about the ADC, analog to
Mm-hmm.
digital converter, right?
Mm-hmm.
So we do use the 0 to 255 values in between
Values.
to like reference the voltage drop from 0 volt to 5 volt.
0
So
volts.
this can be done in the programming itself. Otherwise, it won't give you the proper reading coming from the sensor side.
Okay. Okay.
Okay.
Sir,
Any
I
other
have a
doubts? Yeah, please.
Sir, what's the full form of ICSP pins?
The ICSP pins, one person said that. May you please repeat it
Circuit
once?
serial.
Yeah, go on. Windows HP 1260.
In circuit serial program.
Thanks.
Okay, any other doubts?
Sir, I have a doubt.
Yeah.
I did not understand the concept of analog pins in the analog output. Could you explain that again?
Yeah, sure. So sometimes what we do have is the okay. Sometimes what we do have is two kind of devices. Okay. I already explained that we do have total two kind of devices. One is the digital device and another one is the analog device. Okay. And why we need to have digital device and analog device to integrate in our development board? Because some of the device only requires on and off feature. Remember the LED, we can blink this LED in general, right? We can blink any of the LED in general, but if you look into the some of the these pairs of LED which we use in Diwali or something like that, then it starts fading from zero. It produces the value like 0 to 1. And suppose if we do have the temperature sensor to take the reading from, then temperature sensor won't produce the 0 and 1 because it is not the fixed value. Temperature will be something like 28 degrees C or 38 degrees C or 48 degrees C, something like that, right? You will get the reading something like that, or 18 degrees C, like this only. So it is not the fixed value 1, 2, 3, 4. And you will, if you go for the combination, then you will find that there will be like infinite number of possible combination to have the readings, right? From temperature 0 or minus, even though minus temperature is there, right? So to address the difference, we always use the analog function. So whenever the device does require some of the difference, we always use the analog function. And if the device does require just on and off feature, like we want our device to turn on and turn off, we will use the digital system on that place.
Okay, sir. And what about the analog output?
Both are the same. Suppose if we have to change the speed, suppose if we take the example of motor and using the digital system, what we can do, we can either turn on the motor and turn off the motor, right?
Yeah.
And suppose if we have to generate a systematic speed control, or if we have to reduce the speed or increase the speed, then we will use the analog output over there.
Okay, sir.
Okay.
Thank you.
I will help you with the programming lessons as well by showing you the examples in further classes. Okay, there is nothing to worry. Okay, anyone else? Any doubts so far?
Yes, sir, like so the reset pin just like refreshes the code.
Reset pin actually, suppose we can say that restarting the system. Okay, so what happens after hitting the reset pin? It restarts the system from 0 point. So it will start reading the line, code of line from 1, then executes the remaining portion of the code. So sometimes it happens because this one is the commonest thing we will find in our electronic stuff, like the programmable stuff. The device will stuck because of some power difference or something happened in between. So in that case, we will hit the reset button and it will reset the entire entire microcontroller to, and microcontroller will start reading the program from line 1 and execute the program completely.
Thank you,
Sir, I
sir.
have a doubt.
Yes.
Sir, what are the 6 pins under the reset switch useful for?
These are the power section. As I mentioned earlier, these are the power section.
No,
Okay.
sir, like the under the reset switch.
Yeah, sorry.
So like the reset button is there, right?
Yeah.
Under
Okay,
that there are
this
6
pin,
pins.
this particular pin, right?
Yes, sir.
So these are the ICSP pin, in circuit serial programming pins, which can be used to program other microcontrollers. Suppose other microcontroller does not have proper USB connection, or somehow the USB connector broken or something happened, and also this complete board is not the microcontroller, right? This one in
Yes,
between
sir.
is the microcontroller, and usually we call these microcontroller as EEPROMs. Okay, so EEPROMs means electronically erasable programmable memory. So in place of this complete development, because this development board cost you around 500 to 1200 or something like that. If you go for the original version, then it will cost you around 2700, right? But instead of this development board, if you want to use this microcontroller individually or directly on your development or on in your project, then what you can do is to buy the microcontroller separately, and it will cost you less compared to the development board, and you can directly program that microcontroller using the ICSP pins.
Okay, sir. Thank you.
Okay. And
So,
further, it will also reduce the size of your overall circuitry development. Right now, this much of size is required to be utilized in place of, suppose if you're going for the Arduino, then this much size is required. And further, if you use the microcontroller directly, then the size will be reduced to this size. So suppose if you're developing any smaller robotics devices or the robotics product or the robot itself, then the only microcontroller will be enough to work in the same.
okay, sir. Thank you.
In the beginning, we always come up with the development board because we have to learn something, right? We have to learn each and every basic stuff and everything. The time you will join the engineering college or something like that, suppose if you are developing an advanced application, that time this board will become useless for you, and you will directly utilize the microcontroller in your development. So for a learning perspective, the Arduino development board is good, but for the higher development, like the humanoid and everything, suppose you are developing some of your own product, then you will obviously utilize the microcontroller. Then this ICSP program pins will be helpful in that case.
Excuse me, sir.
Yeah, please.
Sir, when you click the reset button, sir, does it just like reset the code, or does it like delete the code, and do we have to like
No.
upload
Okay.
it?
There are two scenarios. Okay, there are two scenarios as mentioned. So resetting the code is first thing, and deleting the code is second thing. Okay, you have to understand that we cannot able to delete the entire program from the microcontroller. Okay, even though if we try to delete, some of the things will remain on the bootloader, or simply we know that in computer system we do have something known as the the CMOS option in the computer itself to store the data in the boot section or the kernel, and further it will pull out the data from the hard disk and store it to the RAM to be utilized later on, right? So we cannot able to delete. Deleting means deleting the program. So suppose if we have to delete the program, we cannot able to do that. Instead of that, what we do in here, we overwrite the program with the another program. So every time you rewrite the program to your development board, what it does, it deletes the previous one and uploads the new one by overwriting the program on top of it. Okay, and reset button is actually uh, the reset button in your computer. It works like the same way. So it turns off the microcontroller for a fraction of second and turn back is on. So what happens? The microcontroller boots up and it starts reading the code from line 1 to the number you do have the programming length for.
Okay, sir. So it doesn't like lose anything in that fraction
So
of second.
we won't lose anything in between.
Okay,
If
sir.
by mistake hit the reset button, we won't lose anything.
Okay,
So
sir.
program will remain as it is, and further it will just restart the system. So simple to that.
Okay, sir. Thank you, sir.
Yeah, welcome. Okay. Any further doubts from other students?
Sir, I have one more doubt.
Yeah, Ridhima, please go ahead.
Our teacher said that we might, in the arena, we might have sand and water to ride the robot over. So is there
Yeah.
anything you know about that could help us with that? Because we're not sure how to do that.
Okay. To counter the sand and water, so for the water, let's go for the water. Okay. Again, I will pull back that PDF for the competition itself. Okay, so that it will be easier for you to ask the questions based on the requirements. So if we talk about the two conditions,
A paper set on
okay, if we talk about the sand and water condition, what you can do in the water itself, you can wrap up everything, like you can make some airtight seal in between the motors only. You don't have to worry about the same. But if you want your boat to float atop, then you have to provide some of the accommodation in there. I don't know which type of boat you are building. If you help me with the photographs and something.
Actually, sir, I think there is no water. Okay, they might be mistakenly done that one. There is no water. Actually, they are giving path follower things that they will
Yeah.
give some sand, some rocks,
Yeah.
and might be they do some bridge kind of things. We have to cross the bridge. Those kind of things. We
Yeah,
have
they
to.
do have some of the hurdles in between, right? The sand and
Yes.
small stone pallets maybe
Yes.
will be there in the pathways, right? So
Hmm.
to counter attack those things, use the wider size of width, wider and gripped one, wider size and gripped one. So let me show you uh, one of the wheels I do have. This one is the regular yellow wheels. Remember?
Yes, sir.
This one is my line follower robot, and so try to use these kind of uh, wait these kind of wheels, more grippery
But
and
they
more.
have some specification for the robot. Okay, I think this is little bigger.
No, this bot is completely bigger. If we just try to utilize the wheel and motors,
Oh,
then
wheel. You are telling about
obviously,
the wheels. Okay, okay. The bigger
yeah,
wheels.
yeah, we are only talking about the wheels. I'm not talking about the complete body of this
Okay,
one.
okay. The bigger wheels you are
Yeah,
telling.
the
Okay, sir.
bigger and thicker wheels will be good for your application.
Sir, so are the wheels just thicker or
Sorry.
Yes,
friction or something?
thicker wheel is a good one who can avoid this obstacle. Who can cross.
Obviously, the more thicker wheel we will use and the more grippery wheel we will use, then it will impart more friction, right? And it will stay as it is in our surface itself.
Okay, sir.
Okay.
And one more thing, what do you think? Which one is the better? Wire one, wireless one, or autonomous
Okay. If you
to
want to
cross this
go for
obstacle?
the,
Hmm.
see, wired one will give you the difficulties because one person will be engaged all the time to control the bot and the wire, to handle the wires. To handle the wires, it will give you the difficulty to complete the arena. So I won't recommend the wired one. So go for the wireless one, and specifically in wireless one, if you can able to build the model out of NRF module, NRF Bluetooth controller module or something like that, using joystick and every setup to implement the same, then it will be a perfect addition into this competition. Okay, do not use the wireless one with Bluetooth module, because Bluetooth module always get stuck in between and it always malfunction in between. So try to use the NRF module based wireless connectivity in your project.
Sir, can you explain about the NRF model?
Yeah, NRF module is one of the let me pull back the image. Let me gather it from the internet. Okay. So I do have circuitry as well, so I will send you those things. Okay. Okay, let me share my screen with you so that it will be easier for me. Okay, my screen is visible, right?
Yes, sir.
Okay, these are the NRF module. So these module can be used to like address the transmitter side and receiver side. Okay, so one will be placed with the combination of any of the microcontrollers. Suppose if you are using Arduino Nano, so one will be integrated with the Arduino Nano in here to receive the signal from the other transmitter, and further it will send back to the Nano to process and control the motors. And other, in the transmitter side as well, it should be integrated with any of the microcontroller, for example the Nano itself. And also we will have some of the joystick arrangement to move the bot in either of the direction, any of the direction. So
Okay, sir. We can use that RF TX-RX, that module.
yeah, the RX TX, those things, the 433 megahertz RX TX module can be used. Yes, you can use that one as well. That does not require any of the programming. Without the programming, without the special functionality, you can control the bot using the RX TX, the 433 megahertz controllers.
Okay. Okay,
So if you,
I have to
so
check in my lab what we
yeah,
have. Okay, then I will then how we can connect those two.
I will definitely help you with the circuit diagram and everything after this meeting, ma'am, or by tomorrow.
Okay, sir. Thank you.
If you are, because I was entitled to send the detailed diagram for the RF things they bought from the market, right? So I will
Yes.
send you those in the group itself. Okay.
Okay, sir. Okay, thank you, sir.
Sir, I have a doubt.
Yeah, go ahead.
How do we connect those IRSP things to the computer?
Okay, the ICSP pins should not be connected to the computer. It is used to connect the other microcontrollers in between. Okay.
Actually, Rayans, what happened now? If suppose you are only use the microcontroller chip, okay? So you have to put that chip on the breadboard and use some cables, jumper cables. We connect that one to one Arduino using this IC, those pins, okay?
ICSP pin
ICSP
to
pins.
program the other microcontroller.
Then we can do programming on that microcontroller using this Arduino, okay? We know now how to upload the coding from PC to Arduino. We are using the USB one, right? So
Yes,
we are
sir.
using one Arduino to send coding to another controller. Okay, understand?
Yes, ma'am. Thank you, ma'am.
Yeah. So any other questions, guys? Any doubts you do have?
No, sir.
Okay.
Sir, I have a doubt about the reset pin.
Okay.
So, in the Arduino board, what should the reset pin be connected to?
Okay. The reset pin won't need any connection in between because we do have one of the reset button on board, right?
Yes, sir.
So on usual note, we never connect the reset pin to any of the things. But in general, suppose if you want to connect the, suppose if your Arduino board is inside the structure, okay, suppose your Arduino board is completely inside the structure, then what you can do, you can take out this particular wire from this pin and take any of the push button, connect one of the pins in here with the push button, and other pin will go to the G and D pin. It will be shorted to G and D pin. Then whenever you will hit this button, then the reset will be done for the microcontroller. If you want to do the connection, okay.
Okay, sir.
Otherwise, you can utilize the reset button on board, mounted on board. If the structure is not that much of close, or you can able to access the button from the outside box structure or any structure, you can use this particular button. Either way, otherwise you can use the reset pin to make one connection to the push button and place the push button outside the body of the robotics structure, so that it will work the same way.
Okay, sir. Thank you, sir.
Okay, welcome. Any other student? Any doubts?
So, excuse me. So, what's the difference between the three ground pins?
Okay, there is no difference between three ground pins in here. These two and this one are interconnected. The reason why we do have three GNDs in here, because obviously if we are using the microcontroller, then we have to integrate some of the input devices, right? Input devices like IR sensor and others does require the power to run. It does require the power to run. Okay, some of the sensors. There are two category of sensors: active type of sensor and passive type of sensor. If you study properly, you will understand what I'm saying. The 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 specific one does require the power. So how we will supply the power? Using the power section. Suppose one of the sensor does require 5-volt power, then we will pull out the 5-volt pin from here only and supply the 5-volt power. And further, it also, because 5-volt represents the positive voltage, then also we will require some of the negative voltage, right? So GND is nothing but the negative voltage. So these three GND pins are interconnected. There is no difference in these GND pins or the negative pins.
So what's the use of WIN? WVIN.
VIN. Okay. So as I mentioned earlier, the VIN pin is specifically directly connected with the power source coming from the DC jack. So whatever the amount of power we will put through the DC jack, suppose if we are putting 12 volt in the DC jack, then we will receive the same from the VIN pin. And also it can be done vice versa. If we supply 12 volt to the VIN pin, then we can able to pull out the 12 volt from the DC jack.
So what's the use of the AREF?
1 second, sir.
Yes, ma'am.
We can also use that battery, the external source, using this VN and ground, right?
Yeah, the same way I said, the VN pin can be used to like provide the power and also to take out the power, even though we can add some of the batteries. And suppose we are using the battery and other kind of power source, then it does have the positive and negative terminal. So positive can be connected to the VN pin and negative can be connected to the GND pin for the
Actually,
same.
sir, yeah, we're using like this way to give, sometime we give battery power supply to this.
Yeah.
Yeah.
So we can either supply the power to the VIN pin and also we can take out the power from the VIN pin and GND pin for the other application.
So I have a doubt.
Yes.
If we interconnect these two, if these two are connected, can we charge a battery like this?
No. Never do the same. Never do what you said. Okay. So these pins are not does not have that much capability to charge anything. Obviously, there are some power coming out from these pins, but never try to charge the battery using the power coming from anything apart from the charger itself. For charging, specifically charging the lithium ion batteries or other batteries, use a special kind of charger. One of the chargers is TP4056 module. You can use this module to charge your battery. Otherwise, what will happen, if lithium ion battery will get more power than the required one, it will explode. So be careful. Do not try to do the experiment by charging your batteries using these pins. If the power is coming out from these pins, that does not mean that you will do anything of your choice. So never charge the battery using the pins. Always use some of the charging module like the TP4056 or any of the lithium ion charger or any battery charger. Okay, that is why the manufacturers were like selling those products in the market, right? If we can able to charge the battery directly with the pins or the power from the other battery, then there is no need to have those product on the market itself, right?
Yes, sir.
Okay, do
Sir,
not
so
do that.
what is the use of the AREF?
AREF, right? This one is the analog reference pin. Analog reference pin. Suppose if we are taking the reading from the analog devices, okay, so we have to provide the reference voltage for the same. Suppose some of the analog devices does require the conversion of 0 to 5 volt, then we have to, suppose the maximum working voltage is 5 volt, then we have to provide 5 volt to this particular pin to take the reference, how to like do the conversion. Because in programming, we never write the value, like the thing I explained earlier. We do have digital system and analog system, right? So to address the digital system, what we do have 0 and 1, right? But to address the analog system, we do have range between 0 and 1. Means we are talking about some of the value in between 0.1, 0.2. But we never write the value like this in our programming, like 0.1 or 0.2. It won't understand this statement. So to do that, what we do have is the ADC. ADC stands for analog to digital converter. Okay, ADC stands for analog to digital converter, and for that conversion, we often refers to the value 0 to 255 value. Means 255 in here representing the one state, and 0 is obviously representing the zero state. And if we take 150 in between, that means we are talking about the middle value, means 2.5 in between, because we are talking about 0 to 5 volt of voltage conversion, right? So that is why the half of the value will be 2.5 if we take 150 into consideration. So ARF addresses that issue, and if we provide certain voltage like 5 volt or something like that, which is coming from the sensor side, that will act as a reference voltage or reference signal coming from the sensor itself through the conversion take place.
Okay, sir. Thank you, sir.
I will explain you in details. If you join the future classes, I will explain the uses in details by showing you the some of the programming concept and also the setup of different hardware device. Okay.
Okay, sir.
Okay. So any other questions, guys?
No, sir.
Okay. So good so far. Okay, ma'am.
Okay. Okay, sir. Thank you very much. Thank
Okay.
you for your time to give us.
Okay, I will try my best to arrange some of the session for the programming part to
Okay,
clarify each and every doubts like the digital and analog system and ARF and ADC and everything, so that the student will properly understand why to use this system and where to use this system. Okay,
Okay.
and only they will get the
Okay, sir.
understanding, because even though I'm trying my best to explain it using the theoretical portion, it won't be sufficient for you to understand the concept. So until and unless you all go through the practical session, then only you will come to know why and where we need those ARF and others. Even though I will help you with the ICSP programming pins by showcasing the one of the setup to program the microcontroller. Okay.
Okay, sir. Okay, sir. Thank you, sir. Thank you very
Thank you
much.
so much, ma'am, and thank you so much, everyone.
Thank you, sir.
Thank
you,
you.
Thank you, sir.
Good day, everyone.
Thank you, sir.
Thank you, sir.
Sir.
Take care of yourself
Sir.
and God bless you. Bye bye.
Bye, sir.